question number 2. Yeah, all right. So do you remember there is a similar question in your quiz 2, right? 1, 4, 6. Yeah. So here, there is some hidden knowledge there. All right. So if we go back to quiz question number 2, yeah, I do not remember which one, but the polynomial is 1 plus 4x plus 6x squared plus 4x cubed plus x to the 4th. Here, these coefficients, is any of you, if you have knowledge about the coefficients, some special pattern, have you noticed special pattern of the coefficients here? Yeah, most of you may not. So here, let me remind you the special pattern called Pascal's triangle. Pascal's triangle. So what's that? All right. You consider 1 plus x to the nth power. Binomial expansion, binomial, okay? Yeah, binomial expansion, all right. Yeah, sometimes people write a plus b to the nth power. Yeah, but here, let me use the simple example of this. When n equals 0, you get a 1, okay? When n equals 1, you get 2 coefficients. That's 1, 1. Okay? You have, this is, we start drawing Pascal's triangle. Okay? Then when n equals 2, 1 here, the number 2, you add up the 2 numbers of the shoulder, you get 2 and 1 here. Yeah, because you only get 1 number you can use. n equals 3, 1, 3, 3, 1. Okay, adding up these 2 numbers. Okay, then 1, 4, 6, 4, 1, and so on. Here, the one we need here, 1, 5, 10, 10, 5, 1. Okay, yeah. So that's the pattern for Pascal's triangle. Okay, after if you can identify it, you need to be aware of it. You need to be sensitive to the coefficients following the Pascal's triangle pattern. Okay, if you have this knowledge, this is critical piece of knowledge. If you have this knowledge, then you can write it as 1 plus x to the 5th. To the 5th. How about that? Okay. You write in this format. 1 plus x parenthesis to the 5th. And here I ask you to count minimum number of multiplications. We do not count addition. Okay. 1 plus x inside parenthesis doesn't matter because nothing to do with multiplication, right? Yeah. So 1 addition inside parenthesis. After we get this whole number, 1 plus x, then how do we raise to 5th power quickly? The best way. Raise to 5th power quickly. Okay. Yeah. For our quiz question, 1 plus x to the 4th. How can we get the 4th power quickly? Quickly. That means the minimum number of multiplications. We want to get 4th power. Okay. Yeah.
Werner's rule.
Horner's rule, not that fast. Horner's rule, fourth power, you need 3 multiplications. Fifth power, you need a 4th multiplication. We have another way we can do faster than Horner's rule. Faster. Yeah, let me show you. Okay, yeah. So you missed that part. 1 plus x squared, that's 1 multiplication, right? Yeah. We do 1 multiplication, we get 1 plus x squared. Then next one, because we already have the answer for 1 plus x whole thing squared, when we move to 4th power, can we take another square on 1 plus x square? How about that? Square of square. Another multiplication, we get the 4th power. How about that? Oh, sorry. Yeah, I can erase it. Yeah, I saw some of you feel strange. Yeah. How about this? Square. Yeah, because we already have this number. We just take another square on this result number. Okay. Then to the 4th, we only need 2 multiplications, right? How about that? 2 multiplications. For Horner's rule, you need 3 multiplications. This way, we reduce that number 2 multiplications. How about that? Think about the trick. This trick, clever trick. Okay, we call it repeated squaring technique. Yeah. So this method we called repeated squaring. Technique. Okay. Okay. Yeah. But in order to apply this repeated squaring technique, you need something to certain power function. Okay. Yeah. So you need to get a power function. Okay. Yeah. Something to the certain power. Okay. Yeah. All right. For your homework question, 5th power. Can you do a little faster? 5th power. Okay. Better than Horner's rule. You get 5th power. Right? Yeah. All right. So you need to figure out. It's very close. With this knowledge, you need 2 pieces of knowledge to answer this question. Well, Pascal's triangle first, repeated squaring technique second. After these 2 pieces, knowledge equipped, you can figure out. Okay? Yeah. Try to understand the smart way here. Yeah. Let me push another. Yeah. If raised to 8th power, you just need another multiplication, right? Square of 4th power. Square of 4th power, you get 8th power, right? If I ask you 16th power, then square of 8th power, you get a 16th power, right? Think about that. You will move very fast. Okay, yeah. Now, let me ask you, if we want to calculate 1 plus x raised to 1024th power, how many multiplications do we need? The minimum number of multiplications we need. Power of 2. The exponent number, power of 2. Get the rule? Rule. Some rule. When n, so here, when n is a power of 2, we can apply repeated squaring technique to get a minimum number of multiplications. Yeah. 1 plus x squared, 1 multiplication. 2 to the first. Yeah. So let's find the rule. 1 plus x squared, that means exponent number is 2. That's 2 to the first. You need a 1 multiplication, right? Yeah. 1 plus x to the fourth, that's 2 squared. Exponent number, you need 2 multiplications, right? Yeah. 8, 2 to the third, you need 3 multiplications, right? Can you get the rule, right? And here, 1024, we know that's 2 to the 10th power, right? 2 to the 10th. So when n equals 2 to the 10th, how many multiplications do we need? 10. Right? Is it much better than Horner's rule? Horner's rule, look at that, Horner's rule. Horner's rule, we need 2, 3. Huge difference, right? 10 versus 1023. Huge difference, right? See? Huge difference. Horner's rule. Yeah.
So that's because we're doing like the additions on the inside and just like almost just taking the exponent of that number on the inside.
Yes. We do not consider addition. Yeah. Because too little comparing with multiplication 1/10, right? The cost. You know, too little. Yeah. So we do not worry about that. Yeah. So then when you raise to certain power, jump as fast as you can, double, double, double. Yeah. Each multiplication, you double the exponent. You double the exponent every multiplication.
I guess what I'm mainly asking is the only reason we're able to apply such a rule is because of Pascal's triangle. If it wasn't for the triangle, we wouldn't be able to apply it.
That's another thing. All right. Yeah. So 2 separate things. To apply this repeated squaring, we need exponent number power of 2. Okay. But if it's not exactly power of 2, number 5. 5 is not exactly power of 2. But it's close to power of 2, right? 4. After we get 4, one more multiplication, we can get 5, right? Yeah. Yeah. So we try to get the closest power of 2. Then we try to do the extra. Yeah, we need to do some extra work. Okay. Yeah. But for the Pascal's triangle, the goal, we want to get a power function. If you do not apply Pascal, so you get a regular polynomial. It's not a power function, right? Yeah. It's just a polynomial. Okay. Yeah. But this repeated squaring technique we cannot apply on arbitrary polynomial. Okay. Only the special, only the monomial, okay, single term monomial we can apply, but not on polynomial. Okay. Yeah. Monomial case we can apply. Okay. All right. Yeah. Hope you get it. Yeah. You get it. Yeah. This technique is very important. Yeah. Try to understand. And whenever you have a chance, you need to apply this technique. Okay? Yeah. Yeah. We will have further discussion in our review sessions. So I will try to do some more examples, okay, to let you practice. Yeah, because it's important. Yeah. So I will give you this kind of questions in the midterm. Okay, so you need to completely understand this technique. Okay, yeah. Pascal's triangle, so you can search the web, you can find it easily. Yeah. Or you know the rule, you can write on a piece of paper, you generate easily. Okay.